All right, so in our last lesson, we reviewed how to factor and use that to simplify, multiply, divide rational expressions. Today, we are going to talk about adding and subtracting rational expressions. So, two learning goals. We want to be able to find the LCD of rational expressions. And then we want to be able to add and subtract rational expressions with polynomials. Remember that rational just means can be written as a fraction. So all of these are going to be polynomial fractions where we've got variables in the numerator and or the denominator. So just as kind of a warm-up, what I would like for you to do is to complete these two fraction problems below using your brain only. Do not touch the calculator or it does no good because you're not going to be able to have a calculator help you for most of what we are doing in this lesson. So go ahead, pause it, and try to complete these two fraction problems without your calculator. All right, so hopefully what you did in this first problem was you said, I need to make these to have the same denominator. So I'm going to make that common denominator 35. And if I multiplied the bottom by 5 here to get 35, I must multiply the top by the same thing. So 5 times 5 gives me 25. Then over here I multiplied the bottom by 7. So I do the same to the top. 2 times 7 is 14. So then once they have the same denominator, I can go ahead and add the tops. So that's going to give me 39. The denominator stays the same. It does not change. So I've got 39 over 35 for that first one. So if you got that right, give yourself a pat on the back. Let's see if you got the second one right. So common denominator here is going to be 12. So if I convert them both to 12ths, I'd be multiplying by 2 on the bottom of the first fraction. So do the same to the top. 5 times 2 is 10. Over here, I'd be multiplying the bottom by 3. So do the same thing to the top as well. 1 times 3 is 3. So now 10 minus 3 is 7. So 7/12 is my answer. So if I were just to ask you, what is the key to adding and subtracting fractions? Hopefully you would come up with the same two-word phrase. In order to add and subtract fractions, we have to have a common denominator. That is the key. You cannot add and subtract fractions until you have a common denominator. Now, the same thing is true on these polynomial fractions that we're looking at. We can't add or subtract unless they have the same denominator, and when they don't, we're going to have to find it and convert them, just like we did up here. So here are the steps we're going to be going through. First, just like in the last lesson, you have to factor all the denominators completely. You can factor numerators if they factor, but you don't have to. But you do have to factor all the denominators as far as they will go. Then we're going to find the LCD. Now, when we're talking about variables, we have to think back to what the LCD actually means. The LCD is once everything is in factored form, you must take the highest exponent of every factor that appears. And you're going to see what we mean as we go on. It doesn't really make sense when you just read the words until you see it with the example. So once we've found the LCD, we're going to do exactly what we did up here. So after we found the LCD and I wrote the LCD, I converted each individual fraction to that new denominator, and then I added or subtracted. So this requires you to multiply the numerators by whatever parts of the LCD that the original denominator didn't have. Then you can add or subtract, and then we will simplify or factor and reduce again. So we're going to look at quite a few examples here because it takes a couple times to really get the hang of this. Now, we love things like A, because if you look at A, it already has a common denominator, so all you have to do is subtract. I don't have to factor anything. I don't have to do a lot of the steps that are listed there because it's already got a common denominator. So now I can simply do the subtraction. I know the denominator stays the same. 3 minus 7 is negative 4. So now negative 4 over 2x, I just need to simplify that. They're both divisible by 2. So when I divide them both by 2, ooh, my pen messed up there a little bit. That's an x. So negative 2 over x is going to be my answer. And for that one, that's all I have to do. Now, we won't have very many of those. Those are just way too easy, of course. So now we're going to look at one where we do need to do all the steps. So what we're going to do, factor the denominators completely. This denominator is a monomial, so there's nothing I can do to it. Over here, I can factor this by GCF. So I'm going to take out a 3x squared as the common factor, which would leave me with 2x plus 1. Now, remember, factors are all the things that are separated by multiplication. So when we are taking the LCD, once we have it in factored form, we have to take the highest exponent of every factor that we see. So over here, I see a 3 and I see x's. So I have to take the 3 and I also have to take x's. Over here I have x cubed, over here I have x squareds. So you have to take the highest one. So since x cubed is higher than x squared, I'm going to take both the 3 and the x cubed, because it's the higher exponent, as part of my LCD. Now, this whole thing is also a factor. Remember, factors are separated by multiplication, so you're not cutting the 1 and the 2x separate from each other. This itself is a factor, and so I need to take it as part of the LCD as well. So, I did step 1. I factored all the denominators. I found the LCD. Now I need to do the work. I need to convert each fraction into a fraction with the new denominator. So I'm going to use a different color here to make it stand out. So my new fractions are both going to have the denominator of 3x cubed times 2x plus 1. And this one was addition. Now, all I'm going to do, and I put this in the notes here, is I'm going to take the original denominator numerator that I had, which in this case was 4, and in this case was x, and I'm going to multiply them by whatever parts of the LCD were not in the original. So in the LCD, I had the 3x cubed, which I already had in this denominator. So I don't need that part, but I do need the 2x plus 1. That wasn't in the original denominator, so I need to multiply by the 2x plus 1. Over here, when I look at my original, I had 3x squared and 2x plus 1. So the only thing that changed from my original on the right fraction is that the x is one higher power. So I multiplied the denominator by x to get the LCD, so I'm going to multiply the top by x as well. So now they all have the same denominator, so I'm going to write that same denominator just like this, and I'm going to combine these. So I'm going to distribute. It's going to give me 8x plus 4, and then here x times x is x squared. Now what we would do here is we would try to simplify this as much as possible, so I would put it in standard form, x squared plus 8x plus 4. And what I would usually try to do is try to factor that, because sometimes when you factor it, it's going to cancel with something in the denominator. But here, this isn't factorable. There's nothing that multiplies to 4 that adds to 8. So there's nothing I can do there, so this is going to be my final answer. All right, I know it seems very complicated. That's why we're going to do a bunch of these. So next, on C, factor the numerators and denominators, or just the denominators in this case. This is a PST. This is x plus 3 squared. This is a difference of squares. It's x plus 3 times x minus 3. So when I go to find my LCD, remember every factor that appears, I need the highest power that I see of it. So one factor that I see is x plus 3. I have one of them over here and I have 2 over here. So the highest exponent is the 2, so I take that. And then the other factor that I see is the x minus 3. That's just to the first power. I don't see any squareds on that. So my LCD is going to be x plus 3 squared times x minus 3. So next, I am going to rewrite my original fractions with the new LCD denominator. So x plus 3 squared times x minus 3 under both of my fractions. And so now I need to convert the fractions. So my original on the left had the x plus 3 squared, but it did not have the x minus 3. So I need to take the numerator that it had and multiply it by the x minus 3. On the right-hand fraction, the denominator had one of the x plus 3's and the x minus 3, but it didn't have the second x plus 3. So I need to multiply its numerator by x plus 3. So now I'm going to multiply those out and write it as one fraction. So here I have to FOIL. That's a binomial times a binomial. So that's x squared. The outsides are negative 3x. Insides are positive x. Lasts 1 times negative 3 is negative 3. Over here, 1 times x plus 3 is just x plus 3. But here's the thing, I found out on the last quiz, many of you are still not doing subtraction correctly. When you subtract a quantity, you have to distribute the negative. So it's going to be minus x, but it's also minus 3. The negative has to go to both terms. So now I'm going to combine my like terms. I've only got one x squared, so that's it on that. The plain x's, I've got negative 3x, positive x, and negative x. So that's going to give me a negative 3x. And on my plain numbers, I've got negative 3 and negative 3, which gives me negative 6. So again, I would look at that to see if it's factorable, because if it is, we should factor it. So I would ask myself, is there anything that multiplies to negative 6 that adds to negative 3? And in this case, there's not, so that's all we can do there. So that is our final answer. All right. I would like for you to try D, please, on your own. So pause it, try to go through these steps so that you can analyze yourself where it is that you are struggling. If you can't yet do this on your own, this will tell you what part you're having trouble with so that when I'm there to help you, you can ask questions about that specific part. All right, so please go ahead and work this one on your own and then unpause it when you are finished. So hopefully the first thing you did was factor. This bottom factors into x plus 3 times x plus 1. This one is the same as the one we just had, x plus 3 times x minus 3. So when you went to find your LCD, every factor that you see needs to appear in the LCD. So I've got an x plus 3. That's the highest power that I see of that. I've got an x plus 1, so I need that. And then I also have an x minus 3. So all three of those factors are part of my LCD. So now we're to the step where we're going to rewrite. So both of my fractions get this new denominator. All right, so I look, what did this left side fraction have that's in the LCD, and what did it not have? So it had the x plus 3 and it had the x plus 1. It did not have this x minus 3. So my original numerator had the x minus 1, but I need to multiply it by the x minus 3 that it did not originally have. On the right side fraction, we had the x plus 3 and the x minus 3, but we did not have this x plus 1. So the original numerator of x needs to get multiplied by x plus 1. All right, so combining here. So rewrite my denominator. In the numerator, again, this needs FOILed, so that's x squared minus 3x minus 1x plus 3. Over here, this needs distributed, and it's addition, so they get to keep their sign, so that'll be plus x squared plus x. And then hopefully you combined your like terms. So I've got an x squared and an x squared, so that's 2x squared. Then I've got negative 3x, negative x, and positive x. So that's negative 3x. And then on my plain numbers, I've got my plus 3. And rewrite my denominator. Again, we always check to see if we can factor that numerator. So if this were factorable, it would be a split the middle. So we would be looking for what multiplies to 6 and adds to negative 3. Well, the things that multiply to 6, negative 1, negative 6, negative 2, negative 3, none of them add to negative 3. So that also, we've kind of lucked out there, has not been factorable. So that is all that we can do there. All right, hopefully you didn't do too horribly on your own. Let's try one more, and then we will be done. So factoring here, this denominator is already as simplified as it can be. That can't be factored further. This one has a GCF of 3, so 3 times x minus 1. This one has a GCF of x, which leaves me x squared minus 1. Now this is the first time that we've had this. After I do one round of factoring, it's not in simplest form. This is a difference of squares and needs factored further. So x plus 1 times x minus 1. So on my LCD, I've got an x plus 1 as a factor, so I need that. Over here, I've got a 3, and I've also got an x minus 1. Then when I move to the third one, I've got an x, so I'll put that right here. X plus 1 is already there, x minus 1 is already there. So our LCD is 3x times x plus 1 times x minus 1. So here I've got 3 fractions to convert. So first one's a plus. And second one's a minus. All right, so what did my original not have? It only had the x plus 1, which means it needs multiplied by the 3x and the x minus 1. So I had 2. I need to multiply by the 3x and by the x minus 1. Second fraction, it had the 3 and it had the x minus 1. It did not have the x and the x plus 1. So times x plus 1. Third fraction had the x plus 1, and the x minus 1. The only thing it did not have was the 3. So my original was 4x minus 2. It's going to need multiplied by the 3. All right, so I need to do some multiplying here. Here, this is multi-step multiplying because I need to multiply the 2 times the 3x to get 6x. And then I need to multiply that times the x minus 1. So when I distribute that, that'll give me 6x squared minus 6x. Over here, 2 times x is 2x. And then I need to multiply that by the x plus 1. So 2x times x is 2x squared. 2x times 1 is 2x. Over here, first I need to distribute because that's 12x minus 6. But this is subtraction. I always get people miss the subtraction. You've got to distribute the negative to both terms. So it'll be minus 12x plus 6. And that will all be over my common denominator of 3x times x plus 1 times x minus 1. So like terms, x squared. So that gives me 8x squared. Then x's. So I've got negative 6 plus 2 is negative 4, minus 12 is negative 16x, and then I've got my plus 6. Denominator, 3x times x plus 1 times x minus 1. Now, this numerator is going to factor, absolutely. So first I need to take out the GCF of 2. So 2, 4x squared minus 8x plus 3. And then I look to see if it factors further. Oops, I forgot the little x there. So I'm asking myself what multiplies to 12 and adds to negative 8. So there is something that multiplies to 12 and adds to negative 8, negative 6 and negative 2. So this is factorable via split the middle. And I'm kind of out of room here, so I guess I'm going to write it up here. If I split the middle there, 4x squared minus 6x minus 2x plus 3. It's 2x here. 2x minus 3 means this was a minus 1. So it's 2x minus 1 times 2x minus 3. So I've got 2 times 2x minus 1 times 2x minus 3 over 3x times x plus 1 times x minus 1. That is our final answer because it's fully simplified and factored. Now sometimes when you factor you'll be able to cancel things. In this case that didn't happen, but we still needed to put it in simplest form. And there we are. That is it for today.